Hello everyone. So today we are going to explore some of the scaling options for our application that is hosted on Google Cloud Kubernetes engine. So let's first talk about what is scaling. So scaling is one of the most fundamental concepts which will make sure that your application will run smoothly and consistently and with high availability. So let's take an example where your application have very low resources and it causing the application to freeze on the existing load. And one potential solution to fix this kind of a problem is to manually assign more resources to your application. And in Kubernetes, scaling is simply means adjusting number of pods running and the number of resources that are being provided to that particular pod. And this will make sure that all the pods are consistently available and capable of handling variable requirement and variable load across or all the pods. So in Kubernetes, we have two types of scaling options available. One is horizontal scaling, which simply means modifying the compute resources of the existing cluster, for example, by adding new nodes to it or by adding new pods, by increasing the number of replicas or just the pod counts. And another one is vertical scaling. And vertical scaling is means that modifying the resource attributes like CPU and memory for each node in the cluster, and this means creating an entirely new node pool using machines that have a different hardware configuration. Vertical scaling on the pods means dynamically adjusting the resource request and limit based on the current application requirement. So let's put it simply. Horizontal scaling means scaling out or in. It means scaling out or scaling in. This involves like increasing or decreasing number of pods, while the vertical scaling means scaling up or down, which means adjusting memory resources like CPU and RAM allocated to the existing pod. So let's talk about horizontal scaling on GKE. So as we already talked about what is horizontal scaling, which means adjusting number of pods and replicas, but how can we achieve auto scaling of pods? So we have to really talk about horizontal pods auto scaler here. So to achieve that, first we have to make some changes to our deployment.yml file. As you can see, I have added these few lines here, which specifies the resources required by my application or the pod. And as you can see, I specified a request resource. So this is like the resource that I'm requesting for a specific pod, and this is the limit for this particular pod. So it won't go up beyond this particular limit. If it went beyond this particular limit, the Kubernetes cluster will try to gracefully terminate the pod if any time it exceeded the limit that we mentioned here. So for example, in our application, I am requesting 70 MBs of RAM and 50 which is like CPU cores here, like 50 CPU core, not 50 cores, it's like a part of one core. So I'm requesting like 50 CPU cores here. And again, here the limit for my whole pod is like 128 MB. So the application should not exceed 128 MB of resource consumption anytime. And here the CPU limit is 70 MB. And this is what I'm requesting to from the Kubernetes cluster to provide my application with or blocks this much of resources for my application at least. So let's try to deploy like 4 replicas, and we're gonna do that again with the kubectl command. We're gonna do kubectl, apply Kubernetes and the path to that particular file. So our new deployment has been configured on the cluster. And if we go back, check the deployments here under workloads and click refresh, we can see 4 out of 4 pods are running successfully. And we can see the all the pods are running here. And you have noticed one thing that is different from the last time is that these green and the red lines. So if you hover over them, you can see these are the requested limit and the used or the currently consuming resources. So the requested is nothing but the resources that the request limit that we specified here in the deployment YML file, and the limit, the red line shows the limit, which is again came from this specific file. And this is for the CPU, and this one is for the memory or RAM. We haven't specified any such limit for disk size, but Kubernetes have like a default one like 128 MB here. Now let's configure our horizontal pod autoscaler or HPA. As you can see, it is not yet configured here. So there are two ways to configure the horizontal pod autoscaler. One is like to do it from the console. Like you can specify minimum number of replicas, maximum number of replicas here, and which metrics do you want to scale up or scale down. So if you want to scale up on memory or CPU, and then we can specify the target percentage. We have to we can specify percentage or the CPU units and so on. But we are going to do the same using the kubectl command or using the Kubernetes manifest. So here I have created one new file which is hpa.pyml, nothing but the horizontal pod autoscaler file with the kind as horizontal pod autoscaler. And here I specify the name for this particular resource and the namespace, which is MLOps. And we have to specify the scale target reference. So am scaling a deployment, which named as fast API app, which came from this deployment.pyml file. Then I'll specify the minimum number of replicas it required and the maximum number of replicas it can go up. So these are specifically for scaling up and scaling down. Then I specified the metrics which I wanted to target. So I'm targeting CPU resource. If the utilization exceeds 70%, then our application is gonna get scaled up. And if the resource limit is below 70%, then it's gonna get scaled down. Then I specified a behavior. So it's nothing but a scaling up and scaling down behavior. So I'm specifying like scale up my application if the CPU load is above 70% for more than like 60 seconds. So this thing gonna scale my application and it will gonna add 2 new pods every time, every 60 seconds. If the CPU utilization is above 70%, then I specified a scale down set strategy. It's similar to what we have in scale up. So I'm telling Kubernetes cluster to scale down my application when the CPU utilization is below 70% for about like 2 minutes. It will so what it's gonna do, it's gonna start reducing pods one by one because I specified a value 1 here for in every 2 minutes when the CPU utilization is below 70%. So let's go ahead and deploy our HPA file on our cluster. So let's do it with the kubectl command again. Hit enter. So as you can see, the new HPA resource has been created. If I go back and hit refresh, you can see the horizontal pod autoscaler shows unable to read all metrics as of now. So horizontal pod autoscalers take about a minute or two to get activated onto a workload. So let's wait for a few minutes. And one more thing it's gonna do. Right now we have like 4 pods here, but according to our HPA strategy, If the CPU utilization is below 70%, it's gonna get scaled down. So as you can see in the metrics, our CPU utilization is almost zero. It's definitely below 50% or 70%. So once the HPA get ready, it's gonna scale down our application from 4 replicas to 1 replica. So let's wait for a bit. And as you can see, our horizontal power autoscaler is ready now with the status OK. Now we are going to wait for a bit, and after like 2 minutes, because we have specified the stabilization time as 120 seconds. So after 2 minutes, our application gonna get scaled down to single pod after every 2 minutes. So let's wait. So now let's refresh our page again. And as you can see, our application is now scaled down to 1 replica only because our utilization, CPU utilization is like below 70% only. So that's how horizontal pod or scalar scale down and scale up our application. So if the utilization hits above 70%, it's going to automatically scale up our application up to 5 replicas or up to the like 5 replicas is the limit here. It's gonna scale up until the utilization is comes down below 70%. And you can see in the graph as well the usage limit is getting down because the number of replicas are getting terminated every 2 minutes. So that is like horizontal pod auto scale. And talking about vertical scaling or scaling up or down, we kind of achieve the same here by mentioning resources in our deployment.yml. So we are limiting our resources to 128 MBs here for memory and 70 M for CPU. So we are telling the Kubernetes engine to scale up our application till this limit only. And when the but we are not mentioning any CPU usage or limit here, but we sort of did the vertical scaling as well here. The other way to achieve vertical scaling is by creating new nodes into our cluster or by creating bigger nodes with the more resources onto our cluster. So how can we do that? If we go to our cluster and click on nodes. So as you can see, we only have like single node pool here with 3 nodes, and every node have these kind of a memory and CPU memory. So for vertical scaling, we can create one more node pool with the high, basically more computation or more memory usage as per the requirements of our application. It will it will basically scale up the resources for the whole cluster, and we can, so if we our application need more resources like GPU or memory, we can achieve that from the same. So yeah, that's it for this video. And today we have covered about application scaling on Google Kubernetes engine. And we have learned about scaling up and down, which is like vertical scaling, and scaling in and scaling out, which is horizontal scaling of our application. And how can we use horizontal pod autoscaler, which is provided by the Kubernetes engine API, to scale up and down, to scale in and out our application and increase and decrease the number of pods based on the resource utilization. So that's it for this video. Thank you so much.